Direct and to the point. That's a good rule there. Thank you, Mikata. I'd like to welcome our next team. Oh, they got goodies here, too. CNCF. There we go. Who wants to?
Hi, we're CNCF. That's the sound of the jet engine we built spinning up to speed. I think it's a truly awesome thing in the best sense of the word. So when we began our DesignX journey, we had the lofty ambition of creating a clean hydrogen combustion jet engine. But in the process of building this engine, we stumbled upon a problem that I think is more urgent and more broadly impactful that affects all of the players in hard tech, whether you're exploring space, designing the next iPhone, testing for COVID in wastewater, generating power in fusion, or building a better water dispenser. You need metal parts. And we want those metal parts affordably and quickly. Now, as builders of jet engines, we understand metal parts and metal prototyping intimately. And I'd like to walk you through this problem using one of our engine parts as an example. So meet our nozzle plate. Even though we were eventually successful, you can imagine the number of prototypes that look like this. And you don't need to be a trained engineer to tell that this does not look like the part on the screen. Now, to give you context, if you were to buy a block of steel about this size for prototyping, it would cost you about $80. Now, if you're a startup, you don't want to be building this yourself. So you might look for quotes internationally, and that might run you around $500, but now you're limited by international shipping, customs, and so if you're time sensitive, then you're going to be looking domestically, and here's the kicker. For this part to be made in the US, it's going to cost you $1,200. Now, you're probably thinking now these numbers don't add up, and if you guessed that over half of the cost were labor, you would be correct. Since the invention of the assembly line to modern manufacturing, the one constant role that people play in this process has been largely the same for over a century. And that's what motivated us to start CNCF. This is the prototyping service that we all wanted that doesn't exist. The goal is to lower the barrier of entry and make parts faster for the people that are building the important things that tackle challenges. And we want to offer a fast and affordable machining as a service.
The challenge for that is, in order to make that happen, we have to bring mass production level automation into our system. For mass production, every part is the same. The machine is just repeating itself for 10,000 times. But for prototyping, every part is different. That's why you need a machinist from the factory to program the machine and set up the machine, run the machine for each individual part. The challenge is how to make this different process repeatable without human intervention. That's why we're building our standardized factory with standardized machines, and we offer a drag and drop programming interface to our customers. This interface will offer a tool library, operation library that for each operation, they can be easily run inside our factory with zero human intervention, so that whatever you programmed with our interface, the program can be run fast and cheap. Now let's take a deeper look about how this interface works. So the engineers will start by uploading their 3D design file, and then pick the stock material and the stock size. Then here's our patent-pending drag and drop programming interface. Let's start with adaptive clearing. You simply drag that card to the top surface of the part to tell the machine you want to remove material from the top, and then most of the materials are removed. There are still 6 holes near the center, so you just drag the drilling operation to those 6 holes, and then the holes are made. You still have some redundant material at the bottom, so you just drag adaptive clearing again to the bottom surface, and those materials are removed. If you look really close, we have some redundant material at the corners. You just drag the 3D surface finishing to that corner, and then your part is programmed. Now you just need to make sure the cost and lead time is acceptable. You click the order button. The program will run instantly on our machine, and after a short period of lead time,
special delivery.
course, there are other companies out there these days doing more traditional ways of machining service, such as Xometry, PCBWay, SunPay. But the problem is, these days, they either offer a very high cost if you choose to machine it domestically, or a very long wasting time if you do that internationally. So we're hoping that with our automated machine shop and also having our user do the machine programming section, we can reduce both the production time and the production cost simultaneously to bring a much better service to the next level. Our target customers are small-scale enterprise within the United States try to work on hardware innovation. They probably need to do a lot of machining parts. And from the transportation industry alone, we are looking at around 9,000 enterprises who can potentially utilize our service, which corresponding to around 6 million to 42 million of total yearly revenue.
This is our team, Yong, Charles, Scarlett, and myself. And we're CNCF. And help us build a better future faster.
Amazing. Sure.
We do need about 500 grand for our first manufacturing cell, so I brought my hat if people want to chip in $5.
I thought it was like your security blanket. It was like, I always go with my hat. Fantastic, guys. And we can pass the, the hat around and also the little piece of machine.